Okay, so we are moving on from looking at sort of the original origins of life, and now we're going to be starting to look at not just the origins, but how life has sort of evolved through time and what mechanisms are important to understand in terms of biology today. So, one of the first things that we're going to talk about is really what was life like millions of years ago? And what we do to sort of understand that is as scientists is we look to the fossil record. And this is just a picture of Monument Valley um, in Montana, um, and one of the more famous slabs of dinosaur evidence that we have. But it's a lot more than that. This is sort of the fossil record is not just sort of a way for us to understand what life was like, but it's also a way for us to understand a timeline of how life happened on Earth. And so, in your book, you've probably encountered this before in other science classes, but what we're going to be doing in this class is sort of understanding how um, this development of biology on Earth, how that has implications to the biology that we study today. So keep that in mind as we're going through the next few slides. So one of the most important fossils, I think when we tend to think of fossils, we tend to think about trilobites or dinosaur bones. But some of the oldest fossils and most important fossils that we know about are actually things called microfossils. And so the oldest known fossils today are about 3.5 billion years ago. And this is when, just to give you some context, the atmosphere lacked oxygen. And ultimately, what we're talking about when we're looking at these fossils, we're talking about unicellular prokaryotes and bacteria that used other gases as a fuel source. So these are actually microscopic fossils that we use to sort of understand the very beginning origins of life here on Earth. And so again, this is where we're talking about the Archean and the Proterozoic eras. And in that, we sort of have this emergence of unicellular photosynthetic organisms. And then as oxygen began to accumulate in the atmosphere, we had sort of our first multicellular eukaryotic um, organisms. So green algae, we had marine invertebrates, again, thinking about those trilobites. And then we have one of the largest explosions of animal life during the Cambrian explosion. And from there, again, we're just sort of going through, I just want to sort of go through glancing over sort of all these time periods to sort of just give us an understanding of how life evolved. And then sort of once we've sort of had these Cambrian explosions, we start thinking about plants, which again is are pretty new. And the first plants that we saw, and actually this is a fairly recent study from 2014. The very first plants that we saw were probably some form of pond scum. Um, that was on top of the water. But then plants start to colonize the land, and around 450 million years ago. And then we get these mass extinction events where we are eliminating all individuals in a species. This is the Permian extinction, the very first um, mass extinction that we talk about in terms of our history of Earth. But what's important about this is to keep knowing that the survivors of this then spread out, diversify, and colonize newly open habitats. And I wanted you to think back sort of to our last couple lectures in evolution, and think back to again Darwin's finches. So we have these different birds that are going out to different habitats and developing and evolving their own specific um, characteristics and ultimately developing into their own species. So this is what's happening in terms of this longer geologic time. Those survivors are going to new habitats and diversifying and creating new traits. And so this is what we call adaptive radiation. So basically, when species are going to new places, developing new characteristics, and ultimately evolving into new species. And so this continues to happen. So we're having these patterns of extinctions followed by adaptive radiation, and that we can see that in the fossil record. And what we call these things is sort of punctuated equilibrium. So we have these periodic bursts of species change as a result of sudden environmental change. So we're getting sudden environmental changes, then the species are adapting and evolving to their new climates. And this keeps on happening back and forth. And ultimately, this is what influences the distribution of species that we see today. And that's where we're going to pick up next time, is understanding how these idea of punctuated equilibrium and this adaptive radiation has shaped biological life that we see on Earth today. And I'll see you in our next lecture. Speak soon.